guess place to start. Here are some examples. Except for the biggest, heaviest one, we can pass them around if anybody cares, or you can come up later, or whatever. Or I'll be referring to some of these things from time to time also. So, thanks for the introduction. That kind of covers everything I wanted to say, so thanks very much for, for being here. This was kind of an accidental business. I have a slide to show you of the very first housing that I built in 1968, I think. It was out of necessity. Let's see what goes on. Okay, well, I'll come back to those things. I was starting to say that my first housing was accidental. It was, I was going to a community college in Seattle called Shoreline very soon after my late wife and I were married. And our agreement was she was going to work and put me through school, and then I was going to do the same for her later. And so I had planned to go to University of Washington and major in oceanography just after I got out of the Navy and we got married. But ended up not being able to get into UW because of historically poor grades. So I went to the community college there, and that was really a stroke of luck. You know, make lemonade kind of thing. All they had was biology. And so I settled for that, thinking I would go on later to something else. And one of the things they offered was a 2-year beginner through advanced diving class. Now, I grew up in Hawaii. I did a lot of snorkeling, but I never got around to getting certified in scuba. So I began by taking that beginning class that first semester, or first quarter term, whatever it was, and I was amazed. Coming from Hawaii, I knew about lots of kinds of fish and was used to seeing huge variety, but there was a whole lot more variety, believe it or not, in Puget Sound. Even though the water was too cold for me, I bought a wetsuit and did all the things I had to do, and ended up seeing lots of kinds of fish and underwater features and things that I just never knew existed because they were so different from what I saw in Hawaii. So I wanted to take my wife with me to show her all these things too. Well, she was so claustrophobic that she couldn't stand here right now with the mask on her face, dry. So I decided that what I needed to do was to take my one and only little Instamatic camera underwater to be able to bring back photos to show her. It was truly a selfless act. And so I built, and I'll have a picture of it in a little bit, I built my first housing just kind of by accident. And then somebody wanted one like it, and somebody wanted one like it but different, and it just grew. And it was several more years before I actually started a business. But let me, at least with that much of an introduction, this one. Here are some of the early influencers on my life. Top center is my dad. We had that boat starting in about 1955. And then he formed a small company with friends and built 10 copies of this boat after I left home. So I have very little time on that boat, but sorry, I keep moving away. The influencer over here was a young girl who moved into my school, and because I played drums in band, and she played clarinet. We had the opportunity to meet. 8 years later, I married her. She was my first wife, Adrienne. Anyway, and then at some point, I ended up joining the Navy. So here I am on a brief visitation to Pearl Harbor, meeting my brother and sister and mom there. I was on an aircraft carrier called the Ticonderoga, and then here I am on that ship. That's one of the few pictures that exists. Well, these are all exceptions, but with the exception of these are the pictures that exist showing me without a beard. Anyway, so getting back to my dad for a moment, we had a general purpose shop above the garage in our home, and he taught me jewelry making, ceramics, woodworking, of course, fiberglassing, and that sort of thing. And so this picture of him working on a repair on the boat is really a very typical early influencer for me. Okay, when we got to Seattle and got to Shoreline Community College, and I started taking the dive classes. So this isn't, the black and white picture over here is not a real picture of my class, but it's the right era. And we did pool work and then later open water work. And then I followed that with many more advanced classes. And so we got to use equipment like this and many other kinds of then professional equipment. This is late 60s. And then I had the opportunity to actually make a dive in a small portable hyperbaric chamber. I really got to keep this in the right place. Maybe I can kind of hold it like that. And then had a chance to go visit at Virginia Mason Research Center in Seattle, a real high-class chamber. And so again, I don't have any photos from that era, but I searched around, and that happens to be the chamber that we worked with at VMRC. And then during that time, I decided that my little Instamatic in a homemade flimsy housing was really not enough, so I bought an IKONOS. And that was an influencer on my life because this is made by Nikon, a famous camera company, and they built pretty much the only underwater camera. It's an inherently waterproof underwater camera back in the 35 millimeter film days. This Roman numeral 2 is actually the third model of it. It was originally designed by Jacques Cousteau as a Calypso, manufactured by U.S. divers. And it was too late even by then, in late 60s, to get a Calypso without paying an antique price for it. So I got this. And anyway, I can go on more stories about that, but it was a good, useful tool for a long, long time. And then here are a couple of other influencers for me. I never met this guy. His name is Todd Weiler. He published the book that he's showing, which I have, probably in the late 50s, on how to build your own underwater housing. And this is typical of the kinds of housings that he built. They were all cylindrical, made out of acrylic tubing, and then you somehow put a front and a back on it and add controls and whatever you have to do. So he was my mentor, even though I never had a chance to meet him, and I built many housings based on what he recommended. And then the second book is a guy named Paul Zamolis, who was the editor of Skin Diver magazine, and I bought this book in that time frame, and it had lots of good tips and so on. So that was really my starting of all of this. And then there's that first housing. It's made out of a piece of plastic sewer pipe, and It's got a back permanently glued on, which you're looking through here. And by the way, this is before I knew anything about product photography. So here's the light meter in a jelly jar with a lid on it. And for the shallow depths that I was doing, that was sufficient. Here's an example of a roll of film. I made a flash bulb popper out of a 9-volt battery and a capacitor and a resistor, and it had enough voltage and current to be able to go across the saltwater bridge across these and still pop a flash bulb. And it actually worked pretty well. Couple of quick definitions. Basically, an underwater housing is an enclosed box that you put some sort of a camera or other instrument into to keep the water out. I mean, that's as much as we need to go into at this point. And then you do two things. You do a control, which is an external method of controlling the functions on the camera or the instrument or whatever it is from outside and not letting the water in. And then you have connectors. You attach a cable. Here's a good example of one. This is a permanent cable between this housing and this housing. I don't seem to have any others on these, okay? Here's the actual IKONOS. This is not the one that I had, is one that I replaced many years later. But it's pretty neat. And then, let's see. So every place I lived in Seattle and Point Mugu and other places in my career, even before I actually started the business, was I would use my garage or a extra bedroom or something for a shop. Went through many of those, and I don't have those documented, but here's the shop that I'm just leaving in my basement. You can see it's a pretty good size area, really awkward to get things in and out because there are stairs parallel to the edge of the daylight base or basement, which is partially daylight. And so all of these things, even the big saw and lots of other things, had to go up and down a stairway. Anyway, so that's kind of a view of many areas within my shop. And when I started hiring employees, by the time we got 5 employees in here, it was just too crowded. It was the old too many mice in a small cage. And we literally got in each other's ways, got short-tempered sometimes, and so on. So about the time my wife passed away, and this was in 2012, 10, something like that. Anyway, we had already decided to shut the business down or try to sell it because we were going to retire. But it turns out I tried a couple of times to sell the business, and nobody wanted to buy a business that was located in somebody's basement. So that was not a good marketing ploy. Anyway, I gathered my remaining employees, 4 of them at this point, in my living room upstairs from the basement, and said, okay, Adrian's gone now. I would still like to retire, but because of the support that my employees and our customers gave during the time that she was dying from pancreatic cancer, as it turned out, I'm sure many of you at least have an inkling what's involved with that. So many of my customers just said, okay, your job is to take care of her. Don't worry about our stuff. We'll get back with you later. And that level of support that I got from my customers really showed me that they cared enough to let their work go while I was doing my primary job. So decided I didn't want to shut the business at that point because, as you can see, a lot of this stuff is not only unusual, but in many cases it's unique. And there's no other place, no other company that builds stuff like this. So we ended up deciding, okay, we'll keep the business going, but in order to do that, we're going to have to move to a real business location. So here's the corporate building now over by the airport, and we've got lots of big tools and many, many smaller tools, and we're up to, well, we've been as high as 12 or 13 people if you count summer interns. We've had 2 or 3 rounds of interns from OSU and Lane Community College for a few weeks during the summer, and that's been really good for them and for us. So, but it's kind of the big equipment like this we could never have gotten in. You can see it takes a forklift and that's, I think, our first machine being loaded in. That one's long gone, we've outgrown it. But anyway, so now we're going along. I think our present staffing is about 9 people, because I'm kind of sort of gone. And I keep hanging around from time to time. And so that's kind of where we are at this point. I want to give you some examples of some recent projects too. This is Jeremy Childress, who's my president now. And this hyperspectral camera. Hyperspectral means beyond our normal human spectrum that, thank you, spectrum that we can see with our own eyes. We can see a portion of the visible light spectrum, but there's a lot more at both longer and shorter wavelengths than we can perceive. And so this guy, Roger Hanlon, is, and that's him diving there, is an ethnologist. And by that, I mean he studies animal behavior and the physiology that goes along with that behavior. He's interested in many, many, many kinds of things, but his main group that he studies is cephalopods, squids and octopus and such. And he figured that by use of a camera like that that would recognize a much wider spectrum, hence hyperspectrum, that he could figure out how squids and octopi change colors, how they do it quickly, and how they figure out what pattern and surface to match. If you look on YouTube, there are lots of really good things by him and now other people. So we had to build a housing for something that didn't exist prior to that. So we made this machined aluminum box, and we could not have done that in my basement. And so we built custom controls on the tops of the handles here. Can you see the red pointer at all? Okay. Anyway, so this is a 5-sided box machined out of a big block of aluminum. And, oh, no, I take it back. This one was a 5-sided box plus the door, machined out of individual pieces of aluminum so you could get all the details inside that you need, and then welded together, and then more machining and so on. So Jeremy then gives you an idea of the size of this thing. Weighs about 25 pounds in air, and it's balanced so it's neutral in the water. So he's just going along looking at, trying to find the critters that he wants. And then we've done lots, we've probably done, I used to keep a database that I could query to see how many housings total we've done, and that got lost and it's replaced by a proper billing system, and I don't know how to query it, but my guess is we've probably done 18 or 20,000 housings. For example, this one, I can almost barely lift it with one hand. It's one of about 300 that we've done for the Navy. It's a radiation detection meter, and Navy SEAL divers have these, or they have them available at a small boat. They've got a smaller one that I didn't bring, that they wear, a couple of guys on the team wear on their arm, and it just vibrates and flashes a light if it detects any kind of radiation, and then they swim back to the boat and get one of these. Each SEAL team has at least 2 of these in the field, and then they go to the source, and with this instrument they can tell what kind of radiation is, and by swimming towards the source, smart thing to do, by taking periodic readings of the signal strength, they can figure out how powerful a source it is, and then figure out how far to stay away. So anyway, we've done a bunch of these, and there have been several models as we've gone on, and so on. Then this one, PIT tag, I forget what PIT stands for, but it's the kind of identifier that you put into your dog or your cat. It's a little tiny rice grain size transponder. It's not a transmitter, but when it's tickled by a signal close by, then it responds with an ID number. And so I'm sure many of you have put PIT tags in your dogs and cats and parakeets and whatever else. I don't know if a parakeet's worth the cost of a PIT tag, but anyway. We worked with a company called Biomark, and they ended up having such an odd shape of their housing, and they didn't want to do a whole new housing for it to take underwater, or the enclosure, that's the yellow part. So we ended up experimenting with 3D printing. We did the design in CAD as we typically do, and then we figured out a way to make a mold, and then basically put it together. This is number 1, and I don't know whether we've made more or not. A lot of that happened after my watch was over. I think this was last year or something. Anyway, so we've done a little experimenting with another manufacturing technique. It came up pretty good, but it was expensive to do in small quantities. It would be expensive in large quantities too. Okay, so at this point, what I want to do, how are we doing on timing? Okay. Okay, what I'd like to do is show you another slideshow, get out of this, and then come back for the final stuff here. Let's see. Okay, good. And then I want to bring up the other one that's, I think the second one in there, the designing, yeah, that one. Okay, what I want to do is take you through the process of developing a custom housing for a specific application. A guy at Oregon State named Holger Klink is a PhD there, has a lab, and studies elephant seals, and was trying to do brand new kinds of research, not just out there counting them and so on, but what we wanted to do is make an acoustic tag. And the animals he was working with are at Año Nuevo State Reserve near Santa Cruz, California. The university there, UC Santa Cruz, has for about 40 years not taking care of, but have been studying these animals. The area is by and large closed to the public. There can be exceptions to that, but they've been studying this group of animals for all these years. And so, and they do a lot of work too. They use a lot of tags of many sorts, including satellite tags that reports the position of the animal at the moment. They do blood work. They take tissue samples. I mean, whenever they get a dead one from the beach, they pluck whiskers to send to one group. They take out eyes and corneas to send to another group. They take meat to send to other groups, and it just goes on and on. The amazing amount of work that goes on studying all these in the background, but it starts with the field work. Well, most of the tags, as you'll see in a little bit, are about the size of this, and that does not impede their feeding at all, and it doesn't make a lot of drag in the water, so it doesn't impede their swimming abilities. So somebody asked the question, well, what happens if you put a really big tag on one of these guys? What happens to the speed that they can achieve underwater? I mean, it's like putting a scuba tank on us instead of taking a gulp of air to go down. They do the gulp of air thing, but so what we did is and I'll get into the design, but I'm starting with some of the reason for spending a lot of money to do this. So, Elven Seals come in flavors of males, females, and pups. Pups are both sexes, but from the standpoint of research and handling them and all that, the pups are collectively smaller and much easier to handle, and so you try to do a lot of the studies on the pups. But we were needing to work with adults, and since the males are cantankerous, like in other species, the females are much more docile and easy to deal with. And so here's a close-up of a female. They're wonderful creatures, but they're difficult to deal with. You have to be very, very careful. And so there's a big male. These are the ones you see on, see him on TV fighting and trying to capture a harem of females and so on. So had a chance to go along and observe these and take lots of photos. So here's the winner being able to have his way with a female. There, oops. I keep hitting the wrong button. So this guy's the winner. You can tell not by the blood on his coat, but by the fact that he's with her and he's not. So that was the loser of that particular fight. And again, but the purpose of all that is to create the babies. So a baby is about 60, 70, 80 pounds at birth, and then the mother's milk is extremely rich, full of calories, full of fat, and basically able to put on a lot of weight. As soon as their mom dumps them, they get no parental care or support. They quit weaning, or they wean at about 3 to 4 weeks. So 3 to 4 weeks, from 60 pounds to probably 400 pounds. Now, this one, I picked this as an example because this is a big fat animal known as a super wiener. A wiener is a weaned animal, in spite of what some politicians are, anyway. A super wiener is one who has been weaned by his biological mother and then spends as much time as will be tolerated going around and trying to pick up another mother. And so a regular wiener will weigh maybe 250 to 300 pounds. A super wiener is up towards 400 pounds. But studies have been shown that super wieners really don't get any competitive advantage over their single, I'm trying to be nice. Anyway, and the wieners, since they don't know anything, they've never learned how to swim because nobody taught them, so they just sit around thinking, hey, this is a pretty good life. Oh, wait a minute. Okay, so now we'll get back into the real work here. Holger Klink, who sponsored this study in cooperation with UC Santa Cruz, did some literature searching and discovered that nobody knows whether elephant seals make any noise at depth. You know, they don't have echolocation or anything like that, like dolphins and some whales do, but they have to have some way of finding their food. They eat primarily squids and some small fish at huge depths, down to 2,000 meters. And so how do they find their prey? Well, the first question there is do they bark or make any other kinds of sounds when they're at depth? Well, there was no way to find that out because they feed like 2,000 miles offshore when they're not at shore. And then determine whether, as I mentioned earlier, whether large tags affect their behavior, including these things. And then can you coordinate the ambient sounds, which means you have a tape recorder on them? Can you make an association between the sounds that you can record, which should be a proxy for what they can hear? Can you look at what's going on in terms of the sounds with what they're doing? And then we will have tags on them for location, depth, temperature, and swim speed via a real-time clock on all the tags. And so that way you can time synchronize all of these things. Okay. I don't want to take the time to go through all of these, but basically you can see an outline of what happens. They get together and they form these harems, they breed, and then they all go off for a approximately 70-day recovery cycle where they go out and feed, and nobody sees them for that amount of time. Then they come back and have the pups, and then they go off for basically the rest of the year until back in January they start going. And they travel huge, huge distances, like up into the Bering Sea from here, and by here I mean Santa Cruz. These are the northern elephant seals. There are also southern elephant seals that do a similar thing in the southern hemisphere, and they don't get together and mix. So that's basically the life cycle. We have to adapt to their life cycle. So we had to have custom electronics made in time for us to get to Santa Cruz with those electronics in housings and ready to put on the animals, and that's what I'm going to get back to. So basically, they go to 2,000 meters, so we had to design our housings to go 2,000 plus a 1.5 safety factor. We needed at least 96 hours of ambient sounds, and that came from calculations on how much power our equipment took, how much battery power you could provide for them, and how you wanted to divide up that 96 hours. We chose to do 24-hour sessions for one day and one night, a week apart for 4 times. So that's how we came up with the 96 hours. Well, we came up with the 96 hours because that's how much battery we could put into housing that, you know, wasn't 10 feet long. And then I don't know that you care about the ranges. So here we get into now the design. How are we going to pull this off with some kind of housing that's never been built before? So we use aluminum tube because it's light but fairly affordable as opposed to titanium. And then end cap on this cylinder. Remember back the guy who was building the that in that first book, building cylindrical housings. They're generally the easiest kind to build, and as we were looking for ideas, and we explored many, many different ideas, but this is what we ended up with. So I'll come back to a double O-ring bore seal in a little bit, and then had to have attachment points, and the sacrificial zinc is anytime you have aluminum immersed in seawater, and particularly if you have screws of a different material, because aluminum is not tough enough for little tiny screws, you have galvanic action that eats away at the screws. So you have to have zinc on there like you do on a big ship. And then we had to have room for the batteries and the timer and recorder. So we use lithium cells because they give us the greatest power density, that is the amount of power for a unit weight. Normally we use alkaline batteries, but they're big and heavy, and we needed to do something that would really extend the battery life. We had to make custom battery packs of them to fit in our tubes. We had to have a timer board that was built by a guy in Florida that would allow us to turn the recording on and off, because you can't swim out there and catch up with the seal and flip a switch and turn it on. And then we had to modify the tape or the digital recorder with an interface to the timer so it would turn on and off at the right times. And then we used the biggest compact flash cards that were available. We had to cast a urethane fairing. Urethane is a castable kind of plastic that is acoustically transparent, because we had the hydrophone that's recording our data on the sounds that we're trying to record had to go through an acoustically transparent medium and still have the depth capability. Most hydrophones are basically either a solid device or a hollow device. Hollow devices won't take any kind of depth before they crush. The ones that we had would go to 1,500 meters, but we needed to go to double that. So we picked a good 1,500 meter hydrophone and then cased this in this urethane fairing. So I'll come back to that. And then the urethane fairing was also to provide better hydrodynamics, go through the water easier, and hopefully provide some damage resistance, because these guys chew on everything. So here's a CAD view of what it looks like. This fairing, you can barely see the outline of it, but it runs from here over here. You'll see it a little bit more. That's the hydrophone inside, and then this is a stainless steel set of bars that would keep, hopefully, teeth of another animal from breaking this thing. Here's the other end view, and here up on the nose of this is the sacrificial zinc. It's from an outboard motor. So there's an overall view showing battery packs are in here, the recorder's in here. Anyway, hydrophone is there, the stainless guard is inside the fairing, and then the cast urethane fairing is there. There's the battery pack itself. So here's an inside view showing where all these things are. We found out late in the game that we needed a power regulator, which we did not expect to need. And then there's the recorder and all these. Double O-ring bore seal. O-rings are the secret to keeping water out of housings. And every one of these has some kind of O-ring in it. This face seal O-ring is another kind, and that's what's on some of these housings, is only good to as much pressure as you can use to squeeze the O-ring on the door and to the face, or to the housing itself. A double O-ring bore seal, or a single O-ring bore seal, is dependent only on the spacing that you have on each side of the O-ring. They're down in grooves. And so once that is set, it's fixed, and it's independent of outside pressure or the pressure of the door onto the seal and so on. And double one is just belt and suspenders. And so that's why we do that on the deepest housings. So there's the regulator. This is kind of a rear view. And we discovered that there was one instrument that we planned to use and didn't need to, so we threw it away later. I'm just going quickly through these because it's not really germane. This was shown originally to a bunch of engineers. You know, how do you go about designing something like this for this kind of a purpose? We also like to reuse technology when we can, and so there was another group of geologists at OSU who are studying volcanoes. They wanted to use the same thing at the same depth, but they had to use, my slide is wrong. Those are not lithium battery packs, those are alkaline battery packs. Because lithium ones, you've heard about planes blowing up and that sort of thing. Lithium is a metal at room temperature, and if it encounters any water, it will burst into flame. And that's why you have all these problems with lithium cell phone batteries and 787 batteries and things like that. So they're very difficult to transport by air now. And these geologists who wanted to study volcanoes off California needed to be able to fly there, and so they couldn't use lithium batteries. And also on NOAA vessels, with some small exceptions, you cannot. 5 minutes? Okay, I'll run through. We don't need all the design details. Anyway, we went to a different kind of battery for those guys so they could use the same basic equipment. Some design details that most of you probably don't care about. Anyway, there's finished product before putting the fairing on. And so now we're down at the oceanography department at OSU using their chamber to test this. It's a hydrostatic chamber that will go to, I believe it's 5,000 or 10,000 meters. So here we are, we've passed the pressure test, and that's Holger, who's the principal investigator on this. And that's him and me with his wife and our almost finished product. But we still need to design this fairing, And so here's the CAD design of the fairing. And then here is, we had to make a mold to cast the fairing in. And then an attachment to put it on a lathe so we could then make the mold. And I actually have the mold here. So this is acrylic. It's got the shape of the fairing in it, and it will go like so. And then this hole you use to pour the liquid urethane in. So I'm probably done. Pretty skinny. Oops. So you have to mix the urethane by weight. So we had to do a bunch of that. You have to stir it. And there's a video there that you can't see because apparently the connection got lost. But that was actually doing the pouring like so. So that's the mold on a dummy piece of plastic just to make sure the process would work. And there it is. And so there's a real one on a real housing. Here's the recorder that we used, and we had to tear it apart to be able to externalize the power connection and the on-off switch and the record start-stop switch. So that those could be run by the timer. Okay, we got it finished. We went down to Santa Cruz, and now here's Holger calibrating and testing this equipment. We were running late all the way through this whole project because the guy who built the timer, okay. If you like, we can finish up the last of this when we come back. Beg your pardon? Oh, yeah. Okay. We've got 10 minutes for questions, and they can be general or specific. And somebody's supposed to be passing a microphone around. Okay, there's the mic in the blue shirt. Okay. Questions? Yes.
Hi, thank you. I'm Jeanette. I was wondering how large that canister is and how much it weighs. And where do you attach it on them?
I'll come to the attachment when we get to the field.
Okay.
But it's about this big around and about that long, and weighs probably 3 pounds. And I'll show you details of the attachment when we get back to the slideshow. Because the next step in the slideshow is going to be the field trip that I was able to get to go on, which was wonderful.
Well, this is Paul over here.
Hi.
Now, I can see you're designing the housing and all that, which is kind of amazing how you have to go about it. But how about the instrumentation inside? Were you part of that design too?
Indirectly. There was a guy in Florida who designed or adapted one of his designs for a timer to meet our needs. And then that also included the ability to have outputs to provide power from the battery pack through its switch to turn the recorder on and off, and because you wanted to save power. You didn't want to have it even idling during the 23 hours plus 6 days that it was off, because you didn't want it idling during that time. And then, by the way, that recorder, there's no scale there. Well, just to go on a little bit, those two white battery packs are what's providing 4 weeks of power to this thing, so we had to really be conservative. And then this white plastic is just a piece of PVC pipe that the end with the hydrophone is just sticking down there so we could work on this without fooling around. The recorder itself is roughly the size of a pack of cigarettes. Yes?
Hi, this is Susie, And this is so impressive. I want to tell you, I'm so impressed. I'm curious, is it at all dangerous for you to make any of these things with the tools that you use or anything like that?
Yes, it can be. We try to take all the safety precautions that we can. We have a safety officer, one of our people who went to Cal Maritime Academy, and he has been a safety officer aboard ships in that capacity. So yeah, he's doing a good job of running our weekly safety meetings, make sure people know to look for hazards. We also keep material safety data sheets on all the materials that we use. So yeah, we don't want to hurt too much. Anybody else?
Hi, this is Jim. I had a question about, are you privy to the follow-up studies and whatnot? Do you have access to the results? And if so, were the seals were they affected by the size of the machine that they had to carry? And to what depth did they go? Was there a depth meter in it?
Yes. At the end of the slideshow, I'll give you all that. But in general, yes, we are often, but not always, privy to the results or whatever our housings are being used for. And so to keep from spoiling, at the end it shows the results of this work. Anybody else?
Yes, this is Nisha, and I'm
Hi.
here. Do you register this, and then can you sell already made ones to other universities to use in their programs, or what kind of follow-up financially does this help you with?
That's a very tricky question. The vast majority of our work is custom, one of a kind, 2, 3, 4, or even this was custom, but we did several hundred of them in multiple batches. We've built our reputation on doing custom work. You start with a blank screen, or you start with a similar one and change the design to meet the needs for whatever the current thing is. It would be more productive in many ways to have a standard suite of products, and we're going that direction, but there are lots of companies that do that already. The thing that singles us out is that we can do this custom work. So, for example, everybody knows what a GoPro is. It's a little housing like this, and it works very nicely. This is actually in its standard GoPro underwater housing. The camera is even tinier than this. Somebody wanted us to build a housing for a GoPro that would mount on a surf zone and not be attracted to people who might want to get a free one. And it's looking back at the change in the root structure of mangroves next to a surf zone. So this stuck down in a 4-inch PVC pipe that you pounded into the sand, and then put this down and had a way of clamping it. So inside here is a GoPro, not for real, but that's what it would be done. And so we did 8 of them as one job, and then we've had some repeat orders for those.
Yes, hi.
Yes, hi.
My name's Karen. Just curious, did you come down to Oregon for Oregon State University's lab specifically? And would it be equivalent at the University of Washington, or did you come just for other reasons and then start up here?
Well, briefly, how much time do we have? Okay, very briefly, I ended up not going to University of Washington. I ended up, and there's a whole big story, but I ended up going to the Naval Undersea Center at Point Mugu with killer whales. That's a whole nother hour lecture about that. But so I went down there and had some life-changing things going on, and so I never did go there, but I eventually went down to San Diego State, went to Long Beach, Cal State Long Beach, and then in '79 moved to Oregon, and then the rest is more history on that. Okay. One more? We're now down in Santa Cruz at the lab of, I'm blocking on his name. Anyway, one of the professors there opened his lab for us to use for a week or 2 weeks on this project, and we ended up, we got most of one lab that size to get our stuff all ready to go. Calibration is very important. These are, as I say, audio recorders, and we're going to try to collect data from these audio recorders, and so it needs to be reproducible. So you need to be able, as within any scientific experiment, you need to be able to have controls and test subjects. The week before we got there, the week before we got there, this was a team of 7 people from OSU and a few other stragglers from other universities, and then they have their teams there. Their teams went out the week before we did and tagged up, measured all the other things, 5 adult females with everything except our tag. Those were the controls. And in terms of any effects on the foraging ability by adding our giant tag, and you'll see how giant it is in a little bit, they needed to, how much time do we have? Oh, okay, good, we can get through this. Anyway, so we calibrated all the equipment by putting in test signals of known signal strength and other kinds of things. So we knew that on playback of these recordings, a certain signal strength at the frequencies that we were looking for would be reproducible. So therefore, the actual audio recordings of these seals making noise, if they did, would be measurable in terms of signal strength and frequency and all that. So it was a self-controlled experiment in that 5 animals were set up with everything except our big tags, and 5 more animals of the same size range and weight range, and pretty much as equivalent as could be, were set up with everything that the first group had plus our big tag. So let's, if I can find, okay, if I can get this thing going the right way. So just a few shots of Holger getting everything ready to go. Okay, here's a complete tag, 2 of them. We took 5 tags with us. Actually, we had 6, but we were planning to use 5. We always had 1 extra just in case. And to give you an idea, the tags are about this big around and about this long. Yeah. Holger's wife got this picture of me, and I've always loved it. Here are some of the other folks from Santa Cruz. Because it's an off-limit area with occasional brass visitors and such, we all had to wear these jackets or T-shirts with the research emblem on the back. And we did not differentiate between us and them, but we needed to be identified as research people who were supposed to be there. Okay, so here we are. We're looking for candidates to volunteer for this work. So here's a baby with mom. Here's a big male. This is his harem, and he's guarding it and doing whatever he can. Flipping sand acts as a sun coat, if you will. Big male. Another male. And there are males all over the place, like up here, and this guy. This guy's got love in his eyes. This young one, juvenile, is apparently chasing this bird. So now we're really getting down to busy. The other stuff was just fluff photography. B-roll, as it's called in the industry. So now these two women are trying to pick out candidates. Now, what are the candidate criteria that we're using? First of all, they have to have a green flipper tag. They use cattle ear tags for flipper tags, and the green means they were born on this beach. They have a very good birth site fidelity, and so if you pick a green tagged animal, you can be pretty certain, maybe 90, 95, 98% certainty that this animal will always come back to this beach, even though she's been running all over the Western Pacific. So we're looking for green tagged animals. We're looking for good health. We're looking for approximately the size of the 5 controls that were done before. And you had to catch her one more time. So get an idea of the size of these. By the way, that researcher is Samantha Simmons, who is now on the Marine Mammal Commission in Washington. She hates being in Washington. She'd rather be out on the beach. Anyway, to get them to move, you kind of kick the butt and stay out of the way, and they'll eventually move off somewhere. So now Sam is distracting the front end of this female that they've selected, and then Nikki is, wait a minute. Okay, Nikki is putting a syringe into her caudal vein with a mild sedative to kind of get her somewhat immobilized. And then, okay, waiting, as you can see. And then now the animal is completely sedated. What I didn't show is putting in, taking the syringe off the needle that she's already placed, and then putting a basically an IV drop, and then the veterinarian on the team, and there is one veterinarian whose only job is to keep the animal alive and happy and safe, monitors the depth of the anesthesia of the animal by flicking her nose, just sort of this sort of thing, depending on her reaction, and that varies a lot, so that you can really gauge the depth of anesthesia by just flicking the nose. So anyway, so the animal is sedated enough that we can work on her safely for her and for us. This is Sam again, and she is using, whoops. There. She's using an ultrasonic thickness gauge. That's a device that uses ultrasound to measure the thickness of the blubber. And we had laid out a grid, using magic marker on her back of 5 places along her length and top, bottom, left, right, and measured the thickness of the blubber as an indication of the animal's health. And again, this all goes together with weight and such later. And so we're collecting basic data on this animal, and they do this routine on every animal that they capture for this kind of work. Okay, so now they've measured length and girth and those kinds of things. She is recording on a data sheet all the measurement data and things that we're collecting so that we can later compare animals and throw out an animal that is much bigger or smaller than the average for this study if it made a difference. Here is the syringe sticking out of her back. They've already taken off the little IV, but they leave the syringe in, and she's not bouncing around, so she's not in danger of jerking it loose. We've also copied the tag number. It came from the green flipper tag, and I don't see it here. It must be turned over or something. But this 2370 is an easy identifier, and that's done with either light or dark Lady Clairol. And so you can easily see the animal at a distance and know which animal we're dealing with. Let's see. So then, and again, stepping carefully over the syringe that's still there. Medical kit with all kinds of drugs that are useful for this sort of thing. And they're still doing lots of measurements. Okay, now we're starting to attach things to this animal. The towel is to keep epoxy out of her eyes. We're using 5-minute epoxy, just hardware store, onto some mesh that's already been put on and embedded into her fur right here. I'm sorry, the mesh is already stuck here. That's the satellite tag. It's going to tell us remotely where she is, because we need to be able to find her later. That's about it, other than what you can see. A little aside, the 5-minute epoxy that you get from the hardware store produces what's called an exothermic reaction, meaning it heats up while it's curing. It took some trial and error by our predecessors to figure out that in order to keep from burning the animal's skin, you have to apply several thin coats and let it dry for a few minutes between. So it takes a little while to do this process safely for the animal again. I love taking pictures of these guys. My only role on this was to fix something that broke, but the rest of the time was to document the whole process of putting this on. So I took thousands of photos. So we are preparing what we call the saddle. And this is a pressure temperature tag, so we know how deep she was and by the pressure, what the water temperature was, and this is its antenna, because it also has a little radio in it that after it comes back up to the surface, it puts out a direction finding signal, and you can then find it with a direction finder. The satellite tag will tell you approximately where she's back, primarily that she's back to the beach, and then, but it's not precise enough to tell you which animal in that pile she is, or where along 7 miles of beach she is. So we go up with a direction finding receiver and a big antenna to find that. Anyway, so this is the nylon mesh that we're going to glue or I guess we've already started, gluing it with the epoxy that's on that tongue depressor. Glue that to her fur, and then this is neoprene, like wetsuit material, and some straps that all go together to hold our instrument on that area. Okay, so we're putting together the epoxy to bond the whole saddle assembly, but it was done in several pieces because it needed to be flexible because these animals are very flexible. You saw that one male elephant seal kind of reaching back over his back to try to get Sam away from him. Anyway, so we're wearing gloves, and these individual pieces of, it's called a syntactic foam. It's a mixture of tiny glass beads and epoxy so that it's pressure resistant, but the individual blocks are rigid and then will be individually glued through the mesh to the animal's fur, and it forms a flexible base for our instrument to go on. This is another tag that is an accelerometer, and it catches this motion and records it. We're at the tail end of the animal. That's the actual tail. Those are the rear flippers. And this accelerometer just basically catches stroke frequency. You can see how hard the animal is swimming. Nothing new there. So there it's in place. You can see her ID number, and there's one of the flipper tags. And what we do is we put a second flipper tag on so that we have some redundancy. Now it's not the same number as the other, but we have both numbers recorded in the log, so if one tag gets lost, you can cross-reference and see what you have. Okay, now we're going to get a weight. So they have staged about every couple of miles along this beach these great big tripods. So we carry out this sling, heavy canvas over 2 pipes, and there's a digital scale there, and all this stuff we hide in the bushes and then bring it out when it's needed. Oops. Okay, this one weighs 389 kilos, so this is an adult female. That's Holger cranking away. Now he's bringing the tag that we're going to put on her. So now you can get a little bit of relative idea of the tag. And you can see a big wrench there. That's not to attach directly to the animal, but there's a blue here is a strap that goes under all of that stuff, and it's got grommets in the end of the strap, and then a screw that goes into each end of that. So we got a good secure attachment, and then in a little bit there are several pipe clamps that go under the strap that's running above the white blocks and under ours. And so we got a really good secure attachment. We don't want it coming off. Okay, so here we are. Another tag that's on there is a velocity meter. It's got paddles on the inside, and it is supposed to turn freely as the animal goes through the water. And it also records and timestamps that information. Every one of those clogged with sand, though, so we don't have that data. Okay, now we're getting ready to get her down to the water, and the male or a male comes back and wants to go again. So the standard method of getting the animal distracted is to make yourself look big and stomp. And Cindy has done that, not on this trip, but on later trips. Didn't mean to be pointing the laser at you. Anyway, so here we are. We've got the satellite tag and the water velocity meter tag, the find them later, and the pressure temperature. Here's our big tag, and then this is the accelerometer for stroke frequency. Oh, okay, that one explains it all. All dressed up and ready to go. So now she's working her way down. And there are lots of other males trying to get one last shot at her because they think that she is leaving to go on the 70-day foraging expedition, and they're not going to see her again until she gets back. So got to get your opportunities when you can. Lots of males hanging around, some complaining. Oh. And then just as we got her down to the water, male came in and got her again. So what you can see here is, here's her head with her sat tag on it, and here is our housing. Everything else is submerged. This one that I was I documented all of them. I just picked this particular one and series. And then yesterday's is still there. Oops. Oh, there we go. So this is another one. We took a quick shot of each one with their numbered tags on them. And so then we had a party afterwards. That was after the fifth one was tagged. So these were the people. This is the owner of the lab who hosted us, Dan Costa. Okay, so now the satellite tag is giving us readings, or the satellites are giving us readings from the tags. That's the date. And then here is approximately where these animals are. Now, the satellite tags, the quality of the data you get from them is extremely variable depending on weather conditions, altitude, what angle from the transmitter up to where the satellite tag is, weather, all kinds of things. And so you often get spurious data. For example, I'm sure this animal did not go to Oakland. But overall, when you throw out the spurious tags, then you can see where they've been. So here we are a couple of days later. Oops. All 5 of our animals are 1, 2, 3, 4, 5, and they're just going around, and they're out. Average of probably 300, 400, 500 miles. Might even be more than that. I don't know what the scale is exactly, but these are degrees of longitude. Anyway, and then we discovered, or the beach crew discovered as they were walking around doing their other work, that one of our animals was still there and she lost her accelerometer. So they captured her and did all the same stuff to put her accelerometer tag back on her. And the next day she was gone. That's showing where the old one was and the new one is. Okay, so we have some results to share. The 5 control animals, those are the ones done a week before we got there. They all came back, and now this is, we've gone ahead approximately 70 days when we're starting to recover these. We did not get this time to go recover animals, so this was all done by the Long Lab people. So the 5 control animals came back. They were captured weight and all the same stuff done, and they showed the normal expected weight recovery. So one of the questions that the control animals answered is, without our tag, our big humongous tag, they survived just fine the way they normally do. And the Long Lab has been capturing and doing this kind of work for many, many, many years. And so they picked animals for the controls that were representative of the kinds of animals they're used to dealing with, and they were okay. Then our number 4 animal didn't come back. We have no way of knowing what happened. The obvious guess is predation. Probably got eaten by a great white or something. One of our test animals had no recordings. Something failed we got the recorder back. Nothing. So the timer board or something was a problem there. But look at this. All 4 of the test animals showed up with 40% less weight recovery. That is the difference between the normal expected weight recovery and what they got. Well, that basically killed any chance of continuing this work in the future. We had funding and permitting to run this 4 times, on 4 successive years. Can't do it. So the other part is there were surface vocalizations, the arc, arc, arc that you've all heard, but there were no vocalizations when the depth recorder showed them underwater. So that answers another of the questions. Curiously, we heard on the recordings. Now remember, we're recording 24 hours cycles once a week, 4 times, for presumably 5 animals. And in the background of all those were sperm whale clicks. We didn't expect that. Can give a whole nother long dissertation about why that might be, but anyway, so then thanks to the OSU team and the Santa Cruz team and some of the other people who loaned people to us for this. You can see by the number of people that it's really a pretty massive task to go out and do all this work. And in this old slide, I don't have the permit number on here, and I should, but trust me, we actually had a permit to do this. Okay, and that's it for that. Let me get back to the actually, this is it. Oh, okay, this is my last slide on this. I didn't do this whole thing alone. I have lots of people that I want to thank. Yeah, thank you. First, my wife. This was on Maui as she was going through her final stages. And then my current wife, Cindy, over here, who has been just as supportive of my work, and often in different ways, and that's good. And then my people at the corporation, who worked really hard for all of this to enable us to stay in business and do all kinds of things. And then I mentioned at the beginning our lots of customers and friends who told me, don't deal with our stuff, deal with her. And so, again, big thanks to all of those. Questions? Thank you. And by the way, I've got a whole bunch of slides of other housings. I just brought a handful. So if you want to see other examples of other things, when questions are done, we can do that. Okay. First, yes.
How did you explain the lack of weight gaining by your experimental animals?
The people there who study those believe that it's due primarily to the additional drag, both weight that they're hauling around and drag caused by this big thing that got stuck on their back. Yeah. Yes?
I lost track of what you were looking for in that experiment. What was the value of it?
Okay. The reason we spent all that money and time is that they wanted to see whether these guys make sound as an aid to finding squid at huge depths, like 2,000 meters. So we wanted to see whether they have the capability of producing sound underwater. The answer seems to be no. And then the second question posed by the researchers was, do they does the big tag interfere with their ability to carry on with life, specifically feeding? And so I think those two results answer both of those questions in ways that made it inappropriate to continue the study. I think we got quick, good answers. Neither were the answers that we wanted. Yes. Oh, wait.
Hi.
Somebody
I'm
have
Gwen-Ellen.
okay, here we are.
Thank you. I'm Gwen-Ellen, and I'm wondering, while you were there, did you see any evidence of the of them trying to get that off their back, like rolling in the sand, or another sea lion trying to get it off?
We didn't, but we left the day after all those tags were played, because our animals were gone. There's nothing we could do. However, the team that was out working the beach the next many days, I mean, they do this every day, all the time, noticed the one with that was still there, and that the accelerometer tag was off. I'm getting kind of dry. So I did not see, well, the animals that had tags on them were only on the beach for 10 minutes or so. So they got in the water and hightailed it out of there. Yes.
This is Ken. I assume when the experiment's over, you take the equipment off the animal.
Oh, yes.
Does the epoxied stuff come off?
It comes off next time they molt.
I'll be darned. Okay.
These animals do what's called a catastrophic molt, and that means that specifically, unlike a dog or a cat that sheds continuously, these lose all of their fur in one fell swoop, and when it grows back, they're clean.
Over here.
Oh, yes.
I'm Karen, and I have a couple questions, very short. And what's the weight of the item that you put on?
The tank that we put in, I think, was about 3.5 pounds.
Oh, okay.
Whereas
Okay.
most of their tags are kind of this, you know.
Yeah. And going to the sea lion caves, it's very noisy. You know, on the slides, you couldn't tell that there was noise. Was there noise when you were tagging them?
Oh, yeah. Now, the ones you're seeing at Sea Lion Cave are California sea lions, and they are very, very vocal. These are less vocal, even though they're bigger. The males, I wish I could do an example, but they do a very loud guttural beep, and it's amazing. But the females just do a little squabbling, but the males are the ones that really make big sounds. So that was going on in the distance all the time, but we could still hear each other talk and all that.
Yeah, this
Yes.
is George. The seals, they do communicate when they're in higher, shallower water, right?
Well, on the surface.
On the surface, okay. Has any work been done with other seals that kind of dive? Do they communicate?
Yeah. Yes.
The real issue is the depth that they're at then.
Well, and the species. This is specifically northern elephant seal. This is their lifestyle, and we were documenting what we could of it.
Okay.
Other seals do, I don't necessarily communicate, but vocalize underwater.
But they don't stay together when they're at depth. I mean, they're all spread out, so there may be no need to communicate.
Right, and that's probably a good conclusion. They're solitary individuals when they're not on a beach.
Yeah, this is David over here, right here, down in front almost.
Oh, there. Okay, hi.
Yeah. So the information is radioed to a synchronous satellite, I would assume. Is that correct?
No, the only purpose for the satellite is to track where they are. And the satellite, whenever the animal's on the surface, doesn't work underwater, of course. When the animal's on the surface, then it beams up if there's a satellite there, if it's there, and it's not always, then they just get a position information. We're recording all of the sound data and the motion data from these various sensors. Each has its own recorder, and then they have a real-time clock allowing you to take the recordings back in the lab, synchronize them in time, and then compare what's going on as all these events are happening randomly with respect to the recording, but then you can time synchronize the recordings to get the activity to match up with the sounds. Yes, hi.
Hi, Ken. Could you tell us from the time that the seal is injected and you start your process to when you're finished, how, in minutes or hours or whatever, how long are they out when you're working on them? I know you probably have to work, or the other people have to work very quickly.
Yes.
But in timeline, can you kind of give us an idea?
I'd say it averaged 10 to 20 minutes. Yeah, you want to really keep as low as possible the amount of time that the animal is sedated. Yeah. Who's next?
I am. This is Cassia, next to David.
Oh, yes, hi.
It looks like these sea lions are pretty friendly. They don't seem to be upset by having people walking around amongst them. They don't seem like they're attacking them or worried about them being there. Is that a fair observation from your pictures?
Yeah, it's, and first of all, these are seals, not sea lions.
Okay, sorry, sea lions.
And so, and there's a very different level of aggression. These guys pretty much, when they're, the reason they're at the beach at this time is to mate and then to molt. Molting is going to come back about 70 days later when they get back from filling their bellies. So the males, when they're jousting each other for harem members, they get pretty aggressive and they'll hurt people badly. But by and large, they're pretty lazy animals. I mean, they've come back from 70 days feeding at sea, and their dive profile for that whole time, again, based on our data and others, is they come up to the surface from a feeding dive, make about 5 to 10 breaths, and then go back down. And they're down for 30 to 40 minutes, sometimes longer. And then they're back up, a few breaths, go back down. So all the time they're at sea, they are working hard. They're feeding, hunting and feeding. So they don't have time for fooling around on with people on the sand. Yes.
Hi, Ken. This is Dave. So I think you just answered my question. I was wondering how long they hold their breaths and to go down 2,000 meters.
They can hold their breath, I believe, on the northern elephant seal. It's the timed maximum that's been recorded has been something in the range of 50 minutes or so. I mean, they can stay down a long time.
And I have another question. They have those snouts. I assume they use smell then to locate food as well?
No.
No?
No. We don't really know how they locate their food. There's a clue on one of the slides, I think. When we were playing back the recordings, I made a little one-liner saying that there were sperm whale clicks recorded. Well, there's a study going on now that is suggesting that one way or the other, I proposed the first reason for hearing sperm whale clicks as being, what if these guys do have good hearing? What if they go out swimming around, you know, it's dark where they're feeding, so they can't see, they don't have echolocation, but what if they can follow the sound of echolocation of a sperm whale feeding on the same things and just go get pieces of giant squids or whole small squids? And then I've been running this by people. I was going to do a paper on it. I was running this by various people, and one guy said, well, what if it's upside down from that? What if sperm whales who are looking for congregations of squid can hear the activity of the elephant seals smacking their lips and all that, and maybe it's the opposite. Maybe the symbiotic relationship is kind of one way, the opposite direction. Don't know. Yes.
Hi, this is Ken. You didn't mention any test animals as far as the weight goes, so I assume they've done studies before, so they knew how much weight they would expect them to gain on a feeding trip.
Yeah, they were weighed before and after as individuals on this thing, but they were also realized the weight recovery that's expected from having done hundreds of their sisters before. Yes?
Jeanette again. We were able to go, I guess it must have been on a tour through that quite a few years ago, and it is amazing. Those animals are huge, those elephant, the males.
They are.
And when they would get up on their tails and whop each other, they made, as I recall, quite a bit of noise, and that whopping was really loud. I was wondering if you tested the males at all. Do the males follow the same pattern as the females, that is going out to sea and coming back, or is their pattern totally different? And I guess another thing, wondering what you have learned from that study and if there are going to be further studies.
Well, several questions. The males and females do different things, except at the moment of mating, because they're doing that together. The males do a lot more vocalizations than the females do. The females are mostly squabbling among themselves to try to make room within a pile of animals. The males are actively and aggressively fighting for dominance, and in that case it means breeding rights. So let's see, another of your questions was, well, the feeding. I think they all do approximately the same thing in terms of feeding. That is, they all go down to 2,000 meters. I think recently there was a record set by another group where they put a depth recorder on and on a non-tethered animal and was, I think it was close to 3,000. So I hope we made enough depth allowance or safety factor in our calculations. I suppose it's possible that the one who didn't come back, the female, either exceeded the depth that we had our safety factor to cover, or there was a defect in a housing, and it exploded. And if it ruptured, and we had lithium batteries aboard, as soon as they got water aboard, boom, the whole thing caught on fire. So, and that fire is not dependent on having oxygen available around the batteries. So, no way to know, unfortunately.
Oh, this is Sylvie. I didn't see any other hands. I'm
There's
just.
a hand.
Oh, sorry. Go ahead.
Oh, I'm sorry.
Okay, this is Henrietta. I was just wondering if your study had continued for the 4 years, each year would new elephant seals have been chosen, and each year would absolutely new equipment had to be made and put on?
Yeah, I don't know about the selection of animals, but I believe that it would make sense to have fresh animals so that nobody has the experience of having gone through this before. So first year and prior year animals would all be naive to this thing. Had it gone on for other years, yes, we would have improved equipment and probably try to make it lighter and stronger and more battery time. Anytime you go to the field with equipment, you learn things that you would want to incorporate into the next season's work, if you can.
Okay, back to this side again. In the pictures, how in the world did you get the animal into the sling? I saw it was magically. It suddenly was on that mat thing.
Use many people and roll them onto it.
So the rolling didn't take the thing off, right?
No, the stuff was really well attached.
Yeah, and then so it had to be like muscled up onto the weighing device.
Yeah, there's a tripod.
Yeah, but it had to get there somehow.
Well, yeah, and then there's a come along that lowers the weighing device down, or the scale down onto ropes that are on the metal bars, and it all comes up, and presumably you've gotten them centered well enough. Sometimes they're forward heavy or back heavy, and you have to adjust. The ropes that go from the ends of the two metal parts of the sling, the attachment point where they come together, that can be moved along the ropes so that you can kind of balance the animal a little better.
A quick question. This is Carmen, and I was wondering what was the most surprising thing that you recorded that surprised you on your equipment, whether it was hearing or seeing with the photography?
Well, the whole photography thing was fabulous anyway, but I can't count that as being surprising. The most surprising thing to me was finding the sperm whale clicks on the recording. Nobody expected that. And so that has spawned lots of other work. Yes?
D here. Geometrically, is the round cylinder, better at depths than something that would be flatter?
Absolutely.
Okay.
Yes, because the pressure is equal all the way around. Yes?
Hi, this is Jim. I wanted to ask if it ever occurred to you that the housing, which was bright white, could have been perhaps better if it had been camouflaged a bit, made the same color as the sea lions or whatever. As a predator, maybe they were too visible.
I don't know. The housing itself was gray. The pads that it was sitting on were white. I don't have a way to guess about that.
Maybe the sperm whales were talking a lot about the fashion wear on top of the sea lion.
Yes. Yeah, these animals were all blinged up, and that was worth commenting.
Hi, Cassia again. The question was just raised over here about pressure on your instruments. I don't understand how sea lions balance the pressure as they go down. They must have some kind of internal mechanism for not getting crushed at 2,000 feet.
That's a 2-hour answer at minimum, but briefly, we all have a mammalian dive reflex. For example, if you, and I did this in at San Diego State in a physiology class, because we were just discussing all this, part of the dive reflex is when you have your face in water, your breathing rate slows down and your heart rate slows down. Lots of other things too. And what we did in the class was literally to, at our desks, well, at tables anyway, had a little pan of water about this big, put a mask on, and go in here with snorkels, you're still breathing, put your face down while you're attached to a recording device, and sure enough, your heart rate goes like so, and then down quite a bit. Now it was, maybe a 40% reduction or something. But when you have divers who do this a lot, they get a lot less. Free divers, the people who go for breath holding records, get down to like 10% of their normal heart rate. Elephant seals are one of the best divers in the world. So they do all those things, but they also store a lot of oxygen in their myoglobin, the muscular storage of oxygen that's equivalent to hemoglobin in your blood. And they store a huge amount of energy in terms of oxygen bound to the myoglobin in the muscles. And so that powers them for half an hour, 45 minutes in a dive to huge depths. They also collapse their lungs. The cartilages in their trachea and other windpipe apparatus, those are hinged in a way that they collapse down to almost nothing. So they're just all of these wonderful dive reflexes. Looks like
Again, we are out of time, and we want to thank you very much for a fascinating presentation today. And also...